As we've already discussed, for arithmetic sequences, the general term for the nth term is a sub n is equal to a sub 1 plus n minus 1 times d. So how do we actually find the general term of an arithmetic sequence? Well, let's look at a couple of examples. Suppose we have sequence A here with -3, 2, 7, and 12. The first thing we want to do is we want to be able to find the common difference. To do that, you simply calculate the difference between any two terms in the given sequence. Here we can see that D, if we calculate 12 minus 7, D is going to be 5. Since A1 has already been listed, we have all the information we need, and we can say that A sub n is equal to A sub 1 plus n minus 1 times d, which results in -3 plus n minus 1 times 5. And if we simplify that, we get -3 plus 5n minus 5, which becomes -8 plus 5n, or you can write it as 5n minus 8. Now I can find any term in the sequence with that explicit formula. In the second example, A1 is also given, but we don't know the two consecutive terms. We know A sub 1 and A sub 4. Well, we know that A sub 4 is going to equal A sub 1 plus n minus 1. So if we're doing A sub 4, 4 minus 1 times d. So we have everything but this d value. We know A sub 4 is 11 over 6. We know A sub 1 is 1 over 3. So this becomes plus 3d. Doing some algebra here, we get 3 halves equals 3d, or d equals 1/2. We can substitute back in now, and we get our formula to be A sub n is equal to 1/3 plus n minus 1 times 1/2, which results in 1/2 n minus 1/6. Using our third example here for C, I'm going to rewrite it over here to the side. A sub 7 is -8, and D is -3. So we need to calculate A sub 1. A sub 7 is going to equal A sub 1 plus 7 minus 1 times D. We know D and we know A sub 7. So we can calculate -8 is equal to A sub 1 plus 6D. And we know that D is -3, so we can go ahead and make that substitution as well. This gives us -8 is A sub 1 minus 18. Put a plus in there. And so this gives us that A sub 1 is 10, giving us the formula that A sub n is 10 plus n minus 1 times -3, or A sub n is equal to -3n plus 13. These arithmetic sequences can be helpful in modeling different situations. Before we look at one of those, please note that an arithmetic sequence can be defined by 2 terms or by 1 term and the common difference. So I can either give you 2 consecutive terms, or I can tell you 2 terms in general and you can calculate D, or I can just give you 1 term and the common difference, and from there you can figure out any of these formulas. But let's look at an example where we might use arithmetic sequences. If we're looking at population models and we know the population of a small town and we know that it's arithmetic, we know the population in 2012 and we know the population in 2015, but we want to know the population in 2010. If we treat that as the first term of the arithmetic sequence, we want to find the general formula. Since we know A sub 1 represents 2010, A sub 2 is 2011, so we know therefore A sub 3 because we know the population in 2012. So A sub 3 is 12,790, and that also tells us that A sub 6 is 13,150. We can let D represent the common difference. So we know that A sub 6 is going to equal A sub 1 plus 5 times D, but we don't know A sub 1. Well, notice from here to here, it's 3 difference values. So we can calculate 3D is going to be 13,150 minus 12,790. So we get 3D equals 360 or D equals 120. Now we can use that 120 to plug back into our formula. We can use even a sub 3 is equal to the first term plus 2D. So a sub 3 is the 12,790 plus a sub 1 plus 2 times 120. And so when we calculate here, we get 12,790 minus 240 equals A1. So the initial population, which was in 2010, is 12,550. From there, we can calculate the general formula. A sub n is 12,550 plus 120 times n minus 1, or 12,430 plus 120 n.